Hey guys, welcome back to the Zenith porthole restoration project. It's been a few weeks, a few very frustrating few weeks for yours truly. I'm badly in need of a haircut and some rest. I lost some footage, so you're going to see things a bit out of order. We're going to start out with me after I just installed a new dial string, but this CRT won't be installed yet, so I'm actually recording this after I've done all the stuff you're about to see. I hope I can make it coherent because it was quite the troubleshooting adventure, but stick with it to the end. I hope you'll pick up a few things and it has a happy ending. Hey, we have fine-tuning. So as you may have seen in a brief unboxing video I posted recently, I found a new old stock replacement dial string with spring on eBay for, I think it was $4. It was actually Zenith branded. I don't know exactly what it was intended for. It was a little bit longer than this needed. I looped it around twice on the lower pulley, but it was still just a tad too long, so much as I didn't want to, I did undo one of the tied-on strings here and redid it. The reason I didn't want to do it is it came already tied with these nice little eyelets that have a groove in them, so the dial string was wrapped around this groove washer thing and tied off tight, and then was inserted on the end of the spring there. So the way these work, I am by no, this is probably my most, or maybe my only successful restringing to date. At least I did a little research on how this is typically done, since I didn't have the stringing info. There's a hook down here, and you can have a spring hook into one end of that, and go up, and then have both ends of the dial string tie into that end of the spring, and then branch off in either direction. So it provides tension to both sides of the string. I've seen this done in other ways, but that's one diagram I saw that seemed to match how this would rig up. I'll show you the other side here. So on the back side, we have a very similar pulley. On this, I just looped it around twice, kind of looped it over itself. Luckily, there is a coupler here. Couple turns of that, it slid right off, and this shaft is cut here. So I didn't have, that's what I was hoping I wouldn't have to untie it, because I could get the string over both pulleys without actually having to untie it, because there's a break in the shaft here. But yeah, anyways. That was a fun little exercise. Now we can proceed finally, because with that done, I have no qualms with reinstalling the CRT. That was my holdup, because I didn't want to try doing this with the bell of the CRT right next to it. It would have been really tough. Okay, the Widowmaker has been reassembled. Before I power it up, though, I want to take a look at my reference photos to try to get the ion trap more or less in the right place it needs to be to minimize the amount of fiddling I have to do. Similarly, I took off the focus coil while I was working on the set, so that's going to need to get adjusted. So, here's where the high voltage lead goes on one of these guys. It just clips around the metal rim. And that's it. And then this plastic goes over it to provide a little bit of safety when it's back in the cabinet. When it's not in the cabinet, this entire thing from here to here is at the full high voltage potential. This is all metal going directly to the high voltage lead. So while this is powered up, you don't want to get anywhere near in this cone of danger. And gee, look where the channel oscillator adjustment is. Hey, look where the buzz control is. Hey, look where the AGC delay control is, well now. I wonder how they adjusted those back in the day. Okay, for these two, I suppose you get a 2-foot-long plastic screwdriver and do it well out of range. This guy, remember, you need to push this in to engage it, so maybe put some thick rubber gloves on or something like that. Good times. Alrighty, it was a little nerve-wracking, but I got it, in case you were in any doubt. No, it's 8,000 volts there. Yeah, nice. How about a little sound? Well, the sound is great. Just gotta work on the image quality. I'm gonna try a different modulator source. Remember, don't be a Herbert. I swapped out the tubes, checked underneath the hood, replaced one out of spec resistor. Made no difference. So let's just get to it. There's no faster way to resolve an issue with a signal than to do signal injection, whether it be radio amplifier or TV. The only issue with TV is the signal is a bit more complicated, and we have 3 flavors of signal. There's the highest frequency, which is what would come in the antenna terminals. There's the IF frequency, and then there's the actual detected demodulated signal, which is what we're going to start with. In other words, we're going to start with the output. Just as if you were troubleshooting an amp or radio, I would suggest you start with the final audio stage, or even just drive the speaker directly. So we're going to go to the grid of the final video amp tube, at which point it's already been amplified and detected, and we're just looking at a composite video signal. Now, the one challenge is the standard video source, the VCR, DVD player, whatever, converter box will put out a 1-volt peak-to-peak composite signal. It's usually not enough to drive the grid of the video output tube. Also, it might be the wrong polarity. So that's where the TVA92 really shines. So the VG91 on top, universal video generator, can do all the fun test patterns and all that, and IF frequencies and 4.5 megahertz IF. You can either do an RF output, which we can put to the antenna terminals, and that's what I've been feeding in while playing around with this set, or there is a composite video out, standard video output. But this is fixed level. You can't invert it, you can't control the level of it. But if you pair it with the TVA92 below, now suddenly we have 3 ranges. We can do as much as 300 volts peak to peak, and we can flip it. So I will start out with the 1-volt peak to peak, and if that is too low a signal, I'll go to the TVA92. Now, I suspect that's going to look fine. In fact, it should probably look spectacular. In which case we need to go back and go through the IF. As 4 stages of IF amplification. So 1, 2, 3, 4, 6 AU, 6 tubes. But the great thing is, this is the newer 44 megahertz IF, so I don't have to use something like a B&K 1077B. I can use all this stuff, because this does 44 megahertz IF. So for that, I think I can use either one of these. If I need a really high level signal, I can use the bottom. But the top, you can dial in IF, video IF, 45.75. So this can do the IF, not just RF, but also IF. And it can do 3 coarse ranges, low, medium, high, which should be enough to drive this. I don't think you can invert it, though. So as it goes through each stage, typically each stage inverts the signal, because they're all basically triodes. So depending on what stage you're at, you'd want to invert it or not invert it. So I may want to go with the TVA92 for that. Let's take a brief look at the schematic and let's see where we can actually inject this. I believe it has a 12AU7 for the video out. It's a little confusing because they have the tuner, the IF, and then the video amp is over here. That's actually the audio output up there. The video gets sent over this way. So they use both stages of the 12AU7 for a video amp. And they do contrast on the final stage, so they vary the gain of the final stage for the contrast. Functionality. And this capacitively coupled to the CRT. So theoretically I could also inject a signal right on the grid of the CRT, but I think we can just start out here. So we have 2 stages of video amp. I suspect here 1 volt peak to peak is probably enough. They don't show you any waveforms, unfortunately, so just going by just general experience with working on these sets. By the time you're driving the cathode or the CRT, you might be looking at as much as 50 volts peak to peak for that video signal. So yeah, it gets amplified quite a bit. And then for these stages up here, 1, 2, 3, 4, 6 AU6s, we can inject on the grid here, 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 and here, all with that 45-ish IF frequency. So if we go all the way to the grid of this tube and everything's looking fantastic, then we know the problem is in here. And that is my biggest fear, because that thing is a little tricky to work with. Not that the IF stages are any treat to work with either. So inside the tuner you take off some screws and pop it open, and here are the 3 tubes. It's not actually too bad, it's this that's complicated. But that seems to work as I change channels. The local oscillator frequency changes and it's tuning it in, the fine tuning's working. So the local oscillator is working, the mixer is working. That may be the RF gain. Twin lead comes in, there's some coupling caps, a few parts, some inductors. There's not too much to it for the broadband RF amp, the 6BJ6. So I'm really hoping all this is still good and that the problem is in here. So the IF is all down in here. It's basically the same circuit just repeated 4 times. It's a little cramped, it's a little awkward to work at in there. Now this is a split chassis. I forget which. I think at the top is hot, but the bottom is not, or something like that. But of course I'll power this from an isolation transformer, so I don't have to be too concerned. This is my biggest concern. I'm going to leave this installed while I inject these signals and just be careful. The video amp is actually there. So I'm going to see if I can balance this set on its side. Power transformer is over here. So I think I can flip it up this way and expose everything underneath and allow me to inject signals while staying well clear of this. The only issue with this really is doesn't have that spring supporting it like it should. It's relying on this plastic ring up front, which is screwed down there. But if I'm gentle and maybe pushing it with a towel or something, I think I'll be okay. Now when I've done injection before video signal to the video amp, the results were spectacular, so fingers crossed that'll be a great starting point, and then we'll just work our way back. Oh, before we get to that, I want to show you something neat in this service info, something I've never seen before. This covers several chassis revisions that are all pretty similar. So the back is all schematics and parts lists, but the front has theory of operation and block diagrams. And one thing they show is a breakdown of how the tuner works and the local oscillator and IF frequencies for each channel. This is really detailed. If I do need to do any troubleshooting, this is the greatest aid you could ever want. From everything from the vertical integrator, the oscillators, deep in depth on how the tuner works, block diagrams, circuit descriptions. But here, check this out. So there are channels, they skip 1 and they go through 2 through 13. So this is the transmitted signal band, the 6 megahertz block that we want to receive. And this is the corresponding picture and sound carrier. And this is the local oscillator frequency they use on the set. What I thought was neat was, for the lower channels, they use a higher local oscillator frequency, and the difference goes to the IF. So in this case, they are using a higher local oscillator, where you really couldn't go lower, or it wouldn't be as practical. So say we have a 45 megahertz IF and we want to receive 65 megahertz. We could have a 20 megahertz local oscillator. Instead they go 107. But check out each of the higher channels. Now this is lower, not higher. So we saw my TV Alignment 101 talking about tuners. When you have a mixer, when you have a local oscillator and incoming signal and it mixes them together, you get both the addition and the subtraction. So they make use of both. Here they're doing the addition, the subtraction, and here they're doing, they're subtracting the other way. So, kind of neat. So here they're subtracting the incoming signal from the local oscillator, and here they're subtracting the local oscillator from the incoming signal. What that benefits them is that the local oscillator frequency range is not that great. Imagine if you were always wanted this to be higher by 45 megahertz. By the time you're up here, you would need a local oscillator of 270 megahertz or so, which would be a huge range to make one circuit operate over. I've got some sets, you'll see one hopefully in the too distant future, where they actually have two entire separate circuits. One for these channels and one for these. Two separate local oscillators, two separate mixers, two separate RF amps to bridge that gap. But here they did some creative engineering. When I went to the grid of the second video amp, it just looked like garbage. The picture was inverted. It's just not the right type of signal. So I went back a stage to the grid of the first video amp, the first half of the 12AU7, and yeah, got something pretty good. It's having trouble syncing right though, so I suspect the amplitude isn't quite right. But the bandwidth is fantastic. We have pretty good definition all the way out to the far right, which means we have really good bandwidth. So I think the video amp stage is fine. Let's try going into the IF stages up here and see what we can do. Okay, now I'm on the grid of this tube, which is the third video amp. So this is the first one after the tuner. It's the first, second, third, and the fourth. It's a little inaccessible because I have to remove this cover. And it's looking pretty darn good. And the sync is working now. So now I have more control. At this point, I can control the output level. So there it looks pretty good. Yeah, I can control which of these stripes are on and off. I had one of them accidentally turned off, so there we go. So at least if we feed in a strong signal, this is all looking pretty good. So I'll keep working my way back and see if at some point it really degrades. Well, fortunately, unfortunately, no, it doesn't. I'm at the grid of the first IF tube. In other words, the output of the tuner, and it's still looking fantastic. Which means I'm back into here looking at the tuner. Ugh. Oh well. If I got to, I got to. At this point, I think I will see if I can dig up a resistance chart, voltage chart, and actually check the tubes, the voltages on the pins of the tubes, because I can't really inject too much. I mean, I have injected. That's what I was doing. I was injecting a signal into the input of the tuner, and it looked terrible. Not terrible, but it doesn't look as good as it should. Or again, I'm injecting a signal where I have control of the signal level. I don't know what it should be, so I might be fooling myself because I'm injecting too strong of a signal, which is overcoming some defect. Possibly, but so here's an example of injecting a composite video signal directly into the grid of the first video amp. And so it has the same sync issues like I was having with my universal video generator, but the picture quality is outstanding. It's exactly what I'm hoping for. So the set is definitely capable of producing a really good picture, really good contrast, no fuzzies, no static. So it's a matter of narrowing down where exactly the problem is creeping in. I've read through the service info and I feel a little bit better informed now about how this works. Fairly conventional tuner, and then as I said, the 4 stages of IF. It has a germanium diode for the detector. I already checked it and I replaced it. It didn't make any difference. But there's a curious thing. This has gated AGC, which was pretty innovative for how early this set is. AGC, automatic gain control, so they want to vary the gain of the RF front end and IF as the signal strength varies, depending on how far away the station is, how powerful it is, weather conditions, and so on. Well, if you were to just take the average of the signal coming in, remember the video is amplitude modulated, so it varies like crazy with the image, so you can't, that's not a good way to do it. But the one thing that is consistent are the sync pulses. So that's where gated AGC comes in, where they detect the horizontal sync pulse and do a sample and hold with that. Actually, this Admiral nearby does the same, and if you recall, the coil on that was bad, and I had a heck of a time getting that replaced because it was a hard part to find. Well, here's the thing. There's an AGC delay control. It's one of these trimmers I was wondering about around the IF area here. And if I vary that, it has an impact. Sorry, weather conditions are terrible today, so reception is bad. If I back off on that, you see the gain drops considerably. If I go fully counterclockwise, sync back, it gets better. So here it fades out, here it gets better, and this is with it fully counterclockwise as far as I can go. Likewise, the contrast control itself I have maxed out. So between the two, this should be maximum gain, and it still looks pretty crummy. So I'm thinking maybe the contrast, or the contrast controls the gain of the final video amp stage, but the gated AGC controls when it samples the AGC voltage. And there's also a couple associated tubes with that. They use actually it's really annoying. They use same type of gated beam controller they use for FM sound detection, a 6BN6 as part of that. And there's a 6. So it's a goofy tryout. I keep forgetting about it. It's next to the fine tuning circuit here. Be worthwhile checking or swapping that tube out. I've been kind of ignoring those two. So I'm talking about this guy, that's the gated 6BN6, and then there's that guy. Kudos to Zenith for being creative, but it also makes it a bit of a headache to work on. So let's take a look at that. It's a little not so obvious on the schematic either because they have things kind of spread around. So 6AB4, it's just way off there on the far right, just a triode. And just 2 resistors going to it. So that's all that tube does. But that is a sync amp. Now the sync is working, so that seems a little less likely. Oh, I'm sorry. It's a 12AT7 is an AGC amp, but the 6BN6 is involved too, a sync separator. So half of the 12AT7 the 6BN6 and the 6AB4. I haven't tried swapping out any of those, so let's just do that quick, and then I want to check the associated components with them. I also have to begrudgingly admit that I got bit. This is the control I was just adjusting. There's another one here, and I was feeling a little careless. Well, not feeling. I was a little careless, and I thought that if I tipped the screwdriver far enough back, I wouldn't get bit. But I got to about an inch and a half away, and it jumped over, and I got shocked. It's about 9,000 volts. It wasn't that big a deal. It was more of a surprise than it hurt or anything, or that I was in danger of being electrocuted. But just a cautionary tale. It's easy to get careless when you start troubleshooting and the set's working, and especially if you're working a lot of these and you're used to glass CRTs. You gotta remember, this entire huge thing is dangerous, and likewise, if you start hooking up cables, injecting signals and stuff, you can't let any cable get anywhere near that, or you could fry your test equipment. Slight change of plans. Rather than testing those, I pulled out a new old stock 12AT7, nice looking Sylvania. Let's pop that guy in. As I say, I don't particularly care what the tester says. I care how the set works. The tester will not put the same operating conditions on the tube as the set will. Ooh, this AGC controls having a more profound effect, so this is the way it's supposed to be working, I'm sure. Otherwise they wouldn't put this control in there. Alright, so now I'm going to power this guy down, flip the chassis up, get under the hood, and go over those AGC circuits some more. Well, this is getting even more frustrating. I removed this cover, which let me get at the 4th video stage tube and 12AT7 and the others we were looking at, and went over everything. Found a little bit that was out of spec, and I was wrong. The 6BN6 that's here is actually for the sound. 6BN6 for the sync is down here. I found one resistor there was 3 times the value it should be, but that's just for the audio, so that's not going to do us any good. The diode. This is the original diode. Very crusty, ancient-looking 1N47. I replaced it anyways, even though it tests okay. It made 0 difference. So, a more recent vintage germanium diode. And I went over the video amp, and I'm just not finding anything. No smoking guns, nothing out of spec. I also tried driving the AGC bus directly from a variable DC power supply. Strange results. On the schematic it says 0.1 volts for the AGC. I believe that's normal operation. And yeah, with the external supply, basically around 0 volts was when I got the most gain. If it went more negative or more positive, it either kind of went black or went white. Just it killed things. I thought maybe I could artificially boost the gain a little bit and get something, but no, it did not. It did not. So, at least for further experiments to completely eliminate AGC, I think I can just ground it, which takes out all the gated AGC and all that nonsense completely out of it. And then we're just right back to RF in, RF amp, mixer oscillator, 4 stages of IF, and the video amp down here. Well, I think there may be a break in the case. Up until now, I've been using the Zenith factory service manual, which is a very good service manual, very clear, easy to read schematic, great diagrams, parts locator, theory of operation, voltage charts, troubleshooting info. But you know, it's nice to get a second opinion when you can. So I went and bought the Sam's photofact. Sam's photofact is still in business. You can go to their website. You can order any issue that they ever published going back to the beginning. $15 for a digital download. I've heard some issues people have said about the scans not being that good. I've found them to be really good quality, but if they're not, you can request that they rescan it for you. Alright, enough of the plug. So, there's some interesting stuff in the Sam's. It's not in the Zenith. For example, a dial stringing guide. So I didn't get it quite right, but I got it pretty close. So rather than showing a spring going to the middle with a cord going out to either side, they show the spring just wrapping around the middle. But hey, I think I got pretty close. It seems to work fine. Alright, well, the other great thing that just about every Sam's has is the resistance chart. I've told you guys again and again and again. When things aren't working right, when things don't seem right, go to the resistance chart. It's the easiest thing to do. Pop a tube out, generally clip your ohm meter to the chassis, and then go around to the various tube pins and check the resistance. Sometimes, like in this tube I'm just checking, you have to go elsewhere. So, when I got to pin 5, it says it should be 2 kilo ohm with the pound sign next to it. The pound sign means instead of going to ground, go to pin 8 on one of the rectifier tubes. They do that sometimes because of the convoluted power supply design, and I'll show you in a moment why it makes sense in this case. So I popped the tube out, put in one of these handy extenders so you can get easy access to all the pins, and I checked the resistance. And it's not 2K, it's more like 300 ohms. Okay, well, what does that go to? Well, it goes to a 10K resistor down there, which measures almost nothing across it, which threw me off at first, but then I realized, oh, it's going to contacts on the drum, which puts a coil in parallel with that resistor, so that actually makes sense. Okay, and then there's supposed to be a 1K resistor off of that junction as well. I couldn't find it, but I noticed a wire going to the other side. Working on tuners is not fun because things tend to be cramped and hard to see. But if we go around and hunt, there's one resistor I missed checking. And geez, even I have a hard time even illuminating it. Oh man, down in there, next to that new resistor I put in. Well, one reason it's hard to see is because it's charred. There's supposed to be a 1K resistor down in there. It's measuring a couple hundred ohms. That is the RF amp. Went right to the antenna terminals, and that's kind of where, as I was injecting signals and all that, I kept coming back to like something didn't seem right in here, that the signal just was not getting through. So how about we clip that out, double check it out of circuit, and replace it, and I'll also show you what it goes to in the schematic. Here is the schematic. This is the tube we're checking. We're checking pin 5. And sorry, in my excitement at discovering this, I got things a little mixed up. It's 4.7K. The 10K also connects to the same junction, as does a 1K. So the 6 and 7 on here, those are going to contacts on the tuner drum, and a coil gets put in parallel with the 4.7. So that's why that's essentially out of the equation when it comes to the resistance. So let's follow it down. We got 1,000 ohms. That's that charred resistor, and that goes over 100, 100, 400, and this is where I have the other side of my ohm meter. So if we add that up, 400, 500, 600, 1,000, we should have 1.6K. They say 2K. Now, when it comes to Sam's, take everything with a grain of salt, a bit of a fudge factor, because they reverse engineer TVs. They would go out and buy a TV and do this, and then write down the values they would measure. There are component tolerances, whatever. I get a little under 800 ohms, so clearly I'm way off. It should be at least 1.6K. So, let's dig that guy out and replace it and see what difference it makes. Boy, I really hope this is it. That was a pain to dig out, and I don't think we need to test it to see if it's bad. Yeah. When I clipped one of the leads, it just fell in half. So that is toast, literally. Oh man, and here is the new one. I had to disconnect this wire to get at it. You do not ever want to have to work on a tuner if you don't have to. Okay, gonna reconnect that wire, put the shield back on, pop the tube back in, power this guy up, feed in a signal, and hopefully that's it. Well, I dug in there, replaced the 1K resistor, powered it back up, and it made no difference. If anything, things might have been slightly worse. Well, how is that possible? Well, when I initially measured it, the resistance was lower than it should have been. So I think it was fried. It had lowered its resistance, but it was still conducting, so the tube would have gotten power and it would have worked. And it broke in half when I tried to get it out. It couldn't have been completely open, otherwise there's no way that circuit would have worked. Okay, great. So the hunt continued. I checked that tube, 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 that tube, and nothing. Which just left one tube, the video amp, which is way down here. And guess what? I finally found that this coil is open. That is in parallel with the 2.7K resistor. It's what's known as a peaking coil. Another one up here, another one up here. So, it is right there. So if this is open, power will still get to the plate, but not as much. This resistance should be a couple ohms, instead it's 2.7K. I should be able to just short that out with some alligator clips and see if it makes a difference. But ideally that should be an inductor. Why? They're there to help shape the response of the video amp. It's very common in video amps to have these. It helps you get sharper edges, I guess you could say, in the picture. So it would be great to repair it. I'll dig it out. I'll look for a break. Chances are the specs aren't going to be published. But I can try throwing some different values in there. I can guesstimate what the inductance should be. Anyways, let's try shorting that out and see what difference it makes. And that made absolutely no difference. If anything, things got slightly worse again. Alright. I was kind of thinking that probably wouldn't be the problem, because by the time the signal gets to the video amp, there's already a ton of fuzz in it, but I was holding out some hope. So for there to be a ton of noise in the signal but have a decent image, means the signal strength at the final stage has got to be in the right ballpark. So it means the problem has got to be more towards where the signal's coming in. In other words, the signal is getting degraded somehow way here, and then both the noise and the RF are getting amplified and going through all the way. Except I can't find anything wrong up here. At least nothing obvious. All the capacitors are tubular ceramic. Of course, the alignment could be trashed, which is something I've been kind of avoiding messing with. And as I look at this, though, that looks kind of odd. I'm not saying it's wrong, but it's a different color, and the threads are buggered up. It's a little bit... So here's a theory. That resistor could have been failing. The set was acting up, and somebody just started monkeying around with these adjustments. Maybe. Man, I try to do an alignment on this set, but it's not out of the question. That'd be pretty far off, though, to make things that bad.